Malaysia Green Building Council, also known as Malaysia GBC, is an organization that promotes green building programs, technologies, and design practices, aims to make Malaysia an eco-friendly and sustainability place on Earth. Malaysia GBC was founded in May 2009 by a group of passionate building consultants, academia, and representatives. Even since Malaysia's building has increased, the efficiency of resources used in each building was built with green in mind. Malaysia GBC is also supported and associated with most of the top industry institutions. In the year 2015, Malaysia GBC became an established member of the World Green Building Council and known to be the only organization in Malaysia to be supported by the World GBC. Malaysia GBC continues to be the platform that networks, promotes, educates, and most importantly, develops the sustainable, built into the land of Malaysia. With much more passionate industry professionals, we can make Malaysia a greener and better place on Earth.
Good morning, ladies and gentlemen. It is my honor to moderate this session. I am Ahmad Tibri Mashri, the Committee of Malaysia Green Building Council. Malaysia GBC is a non-profit organization that promotes green building and sustainability. We are looking for more green industrial players like you to join us to grow the green economy. All right. We are here today for a webinar titled "Optimizing Pump Selection for a Sustainable, Holistic, and Eco Building." First, allow me to briefly introduce today Mr. Eddie, Development Manager.
To everyone, and also a special thanks to IGEM and MGBC, who has graciously given us the opportunity to make a presentation on this event. So I'm sure many of the topics and subjects presented in these sessions have given us a very good overview on green and sustainability issues in our life, as well as in the environment. And it is really benefiting the industry as we progress to a green environment in Malaysia. Yeah. So as introduced by Ahmad, my name is Eddie Lee, and I'm the Business Development Manager for Ibarra Pumps Malaysia, Sdn Bhd. And for those of you who have heard of Ibarra, we are in the pumps business. And as you may be aware, pumps are one of the most common industrial equipment, second only after motors and perhaps cables. And without doubt, as long as you need water, you will need a pump. And not only that, but as soon as you have used the water and it becomes wastewater, you will also need pumps to bring it out. So much so that even during this pandemic, pumps are considered as an essential service and thus we enjoy the ability to operate where many other industries cannot. So it is almost a foolproof and bulletproof industry, if I may say. So in today's modern construction, pumps are an important equipment in the construction sector, right? And the heart of the water supply system. And as you are aware, water supply is an essential factor affecting the overall quality of the building, while at the same time, it contributes also to the holistic needs of its occupants and users within the building. So in conjunction with today's theme, we will share briefly on how to select the right pumps and optimize the water supply system in a building to ensure, as what the title says, a holistic and yet eco-efficient in terms of performance and energy consumption. Now, due to time constraints, we will not go into all the technicalities of the pump selection and all those, because there's so much to cover. We will just leave all these technicalities to the M&E engineers and the consultants for that. But what we want to do today is just to give you a quick rundown on some of the pumps that are commonly used for buildings and why they are selected. So at the same time, just to keep you engaged, we will have 2 cues for today. Yeah. So what are the Qs and Qs in case you are wondering? So first is quizzes. So we will ask a few questions at the end of the session. And if you can get the answer right, you will get a gift from us in Ibarra. So all you have to do is once we announce who is the lucky winner for that question, and if you are the one, then just send your email to Ahmad, our moderator, and we will record it and we will send you the gift. Yeah, so your email and your address and your contact number. And secondly, we also have a session for question and answers, short one. So in case you have any questions related to pumps or our products or company or anything that you wish to know about Ibarra, you can just type it into the questions box on your interface there. And Ahmad will then again consolidate these questions and we will answer them after the session. So we hope with this tool, you are able to reap a benefit from this whole presentation, both in terms of being the lucky winner, but also at the same time to get your questions answered. So let's start with the topic for today. Now, let's look at this picture. Now, this is a beautiful picture of the skyline of Kuala Lumpur, of course. I think you are familiar with that. And also some of the buildings here. So you can see some of the notable buildings such as the KLCC and the Pineapple Tower there. And maybe some of you have even been involved in the design or the project implementation of these buildings one way or another. Now, have you ever wondered how many pumps are running here to keep all these buildings functioning as it is? Now, if you really think about it, there are probably thousands or even tens of thousands of pumps that are running at any one time in this whole skyline. So you have the cold water pumps, the aircon pumps, or what we call the chilled water pumps, the booster pumps, the sanitary pumps, and many, many more. So imagine the electricity that they are consuming. So an energy study shows that for a typical office building at any one of these buildings, pumps alone account for around 28 to 30% of energy that is used within that building after the lighting, ventilation, and of course some office equipment and all the other services. But pumps alone takes up almost 30% of the energy that is consumed within the building. Now, imagine if with the right pump selection and design, we can save just 20% of the energy consumed in a building from these pumps. Now, how much will that translate to, not only in terms of operational costs, but more importantly, how much can that saving reduce the carbon footprint of our environment and lead to a more green environment? So just think a little bit about that as we progress with this presentation. Now, let's look very quickly at a typical electricity consumption in a building, let's say a high-rise building, like an office tower. Now, as mentioned earlier, research and a lot of energy audits have been done, shows that pumps account for almost 30% of energy consumption. Now, this ratio, of course, depends very much also on which part of the world the building is in. And of course, in a tropical country like Malaysia, we all need air conditioning all year round. So the biggest energy consumer will be pumps used for the aircon systems. We call it the chilled water systems and the condensate systems and the cooling towers and so on. So that's also where the biggest pumps in the buildings are. And these pumps can range anything from 50 to 100 horsepower or even more, depending on the building size. And not only one pump, you can have up to 6 or 8 pumps of this size running for the aircon systems. So typically these chilled water pumps run in variable speed, where the pump can be regulated to adjust its speed according to the temperature loads of the day. And the next, of course, after the aircon pumps would be the water supply systems, where the booster pumps, the transfer pumps are used for the pumping and distributing of water in and out of the building. So in this case alone, now research has shown that if you read there, energy efficiency for high-rise water supply system is below 25%. And actually more than 75% of the energy or the input energy is actually lost. Now, what does this mean? Is basically what it's saying is that by using the wrong pumps or wrong pumping method, there is a lot of inefficiency in the water supply system, thereby making it consume more energy to distribute water in the building than necessary. So this presentation will cover these two aspects, but at the same time, before we get too technical, what we want to just present to you today are some of the common pumps that are used in the building and why it is selected to be such, or rather to be used. These pumps are to be used. Okay, so it will be a simple presentation like Pump 101 for this afternoon to you. Now, let's go back to the basics first. So for those who don't know much about pumps, or in other words, we call pump illiterate. Now, where are pumps used in a building? Well, the reason I say is simply because whenever you are inside a building, you normally don't see the pumps. They are always in the pump room, on the rooftop, or even basement, where normally only the maintenance team get access. So many do not realize, I mean, the common public do not realize that there are many pumps working inside a building at any one time. Nevertheless, as you can see here, whether your building is a high-rise modern office like this, or a residential condominium, or even a shopping center, or a commercial building, many types of pumps will be used to serve all kinds of application, both inside and outside the building. And the pumps, as mentioned, could be for the general water supply and transfer, for pressure boosting to all the various water demands areas, such as toilets, bathrooms, restaurants, kitchens, and so on. the hot water circulation in hotels, and as mentioned, the air conditioning and even fire protection systems. A lot of pumps are being used to ensure that you get very high pressure water for the sprinkler systems, for the wet riser systems, for the hose reel systems whenever a fire occurs. And pumps are also used for not only inside the building, but also outside for sewage, for wastewater, rainwater, and even for landscaping works around the building. So in short, there will always be pumps in any building. So today, we will just talk about 5 of the most common pump types in building services. And from there, I will just go through in very brief, but gives you a good understanding of what type of pumps are these and why they are used and how they optimize the application within the building. So over here, what are the 5 most common pump types? We talk about vertical multi-stage inline pumps, pressure boosting sets, which is part of, usually you can, part of the vertical multi-stage pump is built as a package set where we call it pressure boosting sets, and suction pumps, horizontal split case, and not forgetting for the wastewater, you have this dewatering and drainage pumps. So these 5 pumps represents the best in terms of value, in terms of performance and operating efficiency. And these 5 pumps has been proven popular, proven in many building installations. Okay, so we will go into what makes these pumps popular, how and why they are selected for that particular application within the building. Okay, so let's start with the first pump. Now, you, of course, if you are in the building line, you would have, of course, seen a pump like this. This is called the vertical multi-stage inline pump. Now, this pump, as you can see from here, the word itself is a vertical pump, and it is of a multi-stage design. So it has many good design features, and it's actually an excellent choice for normal water transfer within the building, or even for pressure boosting to toilets and fittings. So what are the good features of this pump? First, if you look at the construction of the pump, these pumps are usually made out of either stainless steel 304 or 316 construction. Now, stainless steel is a good material for pumps because it is resistance against long-term corrosion. And stainless steel also is considered a clean material. So especially for pumping water, it does not lead to browning or water rust like let's say a cast iron pump. And if you leave the pump not operating for a long time, it will not have rust. As mentioned before, compared to an end suction pump, which is made of cast iron, which you will get brown water coming out. So this is one of the good feature of this pump. Now, secondly, if you look at the design alone, the vertical pump design makes it space saving and easy pipe work with just in and out in the same line. That's why it's called a multi-stage inline pump. So that allows you to save a lot of space in a pump room compared to a horizontal. You don't need a lot of elbows and so on, and pipe hangers for this pump. And thirdly, due to the vertical design, where the motor actually sits on top, the pump does not require any form of shaft alignment. So it is already true aligned, and with that, you do not need to align the pump and motor unlike a traditional horizontal style pump. And not only you don't need to align the pump, but it also have much lower operating noise. So because of that, vertical multi-stage pump like this can actually run for years and years without requiring any form of maintenance, as long as it is installed and kept well. without dry running. You don't staff the pump, and of course with some occasional inspection. These pumps are almost maintenance free. And one important point is this pump is designed for high pressure operation in a small footprint. So a lot of the high-rise buildings will use a pump like this because it can deliver more than easily 20 bar at its maximum stages. And even for the tallest buildings in the world, like the Burj Dubai, or even like our KLCC and all the what's that? Now it just slipped my mind. The latest building, the 106. Yeah, all these would be using this type of vertical multi-stage pumps. And one of the characteristics of this pump is actually the build-up of axial thrust. Now, because the pump is pumping all the way up, it creates a lot of axial thrust on the pump. So we at Ibarra have developed and patented a new impeller design. We call it the S Hurricane design. And this actually improves or rather reduces the axial thrust of the pump considerably. And with that actually creates a long life for this pump compared to many other traditional design or traditional multi-stage design. So without saying too much, let's now just watch a video on this new EVMS pump so you can understand how, or rather the inner workings of this pump. So Ahmad, can you play the video? I will stop share.
Yeah, the video is playing.
Okay, so video I finished, yeah? So let's now go to the next pump. You can see from there how the vertical multi-stage pump is constructed. Now now I seem to have a little bit of problem. Just hang on a minute. Okay, oops. Now it's back to not the full screen, is it?
This one is okay. This one is okay. You can continue with the presentation. With the next slide.
Okay, so the next. Now, sorry, do you see a full screen or with my notes now?
It is a full screen now.
Ah, okay. So,
Great.
okay, apologies. Sometimes you have to press a lot of buttons just to get this Zoom working. Okay, so the next pump that we will talk about, which is also a very common pump inside the building, is what we call the end suction pump. And this is actually one of the oldest pump design in the market. And this design itself is more than 100 years of pump manufacturing, but it has stood the test of time for many, many reasons. And normally these pumps are used for general water pumping, where you require medium to larger flows, but not at a very high pressure, unlike the multi-stage pump. So as you can see from this pump, it is a cast construction. So typically from cast iron, and the reason is because with a casting process, it is able to achieve a strong and a robust casing that can withstand high pressure and dynamic stresses that is inside the centrifugal, or rather that absorbs the centrifugal forces of the pump. And another good feature of this pump is also that it can be driven various types of prime movers. When we say prime movers, means either motors or engines, and even in some traditional, let's say, applications, they use belt and pulley systems, you know. So in a building, of course, most of the time, this pump will be driven by a motor, but in some firefighting application, in case the electricity fails, then there is a backup using a diesel engine driven, as you can see from the picture. So in terms of maintenance, this type of pump is what you call a BPO, or back pull-out design. You can see from the picture here, let me just do the pointer, okay, where the pump elements can actually be removed from the casing without affecting the pipework for maintenance. And this is a very good feature in this pump, so that you do not affect the pipework and you do not need to remove a lot of the, the flanges and the bolts, because once you remove this, then sometimes it upsets the alignment of the pipes. So in this way, you can actually get access to the pump without having to dismantle the whole pump out. And not only that, but importantly, a pump like this is manufactured to a recognized international standard. And what we mean is that it follows a certain dimensional standard, for example, like EN 73 or ISO 2858, so that what happens is that if you are replacing another pump, for example, from another brand, and that brand also conform to this standard, then you can easily replace it with our model without affecting the pipework dimensions. That means it will just fit properly. So there's what you call a standardized dimensions for this. So in that sense, it is a very, let's say, friendly pump to be used in a lot of applications, especially for old buildings where you need to change the pumps. Okay, so with that also, let's watch another video on this pump, so you get a bit more understanding on how the pump is manufactured. Okay, so you can see from the video how an end suction pump construction is like. So now let's move on to the next type of pump. And this is actually not a single pump, but rather is known more as a package booster set. Okay, so now why do we need a package set like this? Well, the simple purpose is to regulate supply water to a variable demand condition, such as those for toilets, water fittings, and general use, where the flow demand is always varying. Now, picture this, for example, like in this picture here, a public toilet, okay, in a building. So in various times of the day, let's say a shopping center. Of course, now shopping centers are very quiet, but let's just rewind back 2 years ago where, you know, shopping centers like One Utama and Sunway Pyramid, full of people. So in various times of the day, the toilets can be filled with many people or very few people, let's say early morning or late nights. So nevertheless, when water is used, we need to ensure that all the fittings receive a constant water pressure to ensure a comfortable supply. Or even for a multi-story condominium building with many water demand points for each household unit. Yeah. So depending again on the time of the day, water demand will vary according to the number of users or occupancy of the building. So if you have like very early morning where people get up, they wash, they shower, then there'll be a lot of water demand. But as people start to go to work, and then water demand will come down. Again, in the evening, when people come back, they start to wash, shower, cook, and so on, then water demand increases a lot more. So again, the job of the pump system is to give a constant pressure irregardless of the flow demand. So by having a pump system with a multiple pump arrangement like what you see, a package booster system, it is able to achieve this variable demand condition, but ensures that the pressure is always supplied at a constant pressure to all the fittings. So now, how then is a booster set like this? As you can see, there is package, but basically what does the package consist of? You can see from here, it consists of the pumps, and this can be easily anything from 2 or 3 or even up to 6 pumps built as a system with full accessories such as a fully dedicated control panel, which houses all the electrical starting gears and the variable speed drives, the suction and the discharge pipe work, and even a small diaphragm tank to absorb pressure fluctuations. We have a pressure sensor and pressure gauges, and all these accessories are mounted on a base frame for easy installation at site. So it's like a plug and play system. And this system uses our own variable speed technology to control the speed of the pumps so that it allows for very smooth regulation of the pump irregardless of the water flow demand. And with that, you actually will not feel any pressure difference at your fittings at any time of the day, regardless of the demand. And not only that, it also reduces the shocks that are created in the water supply of the plumbing system due to the variable speed or the constant pressure operation. So you can see a few of the variation from these pictures here. Some systems you can have up to 2 pumps, 3 pumps, and so on. And if you go into the pump room of any building, you will usually see a pressure booster set like this. And even on the rooftop, usually they are used to pump down to the top 2 or 3 stories due to the fact that the gravity pressure from the rooftop tank is not high enough for the fittings. So this is what we call a pressure booster or boosting system, which is a package system. Next, pump that we talk about, or as mentioned before, that's usually used in a building would be what we call the horizontal split case pump. And this pump is usually a rather large pump. And as mentioned, it could be also be the biggest pump in the building. And why is it called a split case pump? It's for actually a very obvious reason. You can see from here that the case of the pump, the casing, can be split along its axis. So what it does, or why this, the very good reason is that the casing can be opened up to get access to the internal parts of the pump without having to remove the pump from its base plate and piping, and thereby saving a lot of maintenance time and labor. So imagine a pump like this can easily weigh up to almost half a ton or more. And if you were to have to dismantle this pump, and if you do not have a case that can be split, then you have to remove the whole pump. And that takes a lot of time, labor, and all the handling tools and so on. But with a split case like this, you can easily get access to the elements of the pump without affecting the suction and discharge pipe work. So it is a very good design pump, especially for a large flow application. And not only that, but not only in horizontal style, but also vertical style. So we also supply vertical split case, and this has been also installed in many buildings around Malaysia. So where are these pumps used? As mentioned before, they are meant for medium to large flow application. So it will be commonly used for a larger building with centralized air conditioning systems, which will pump large amounts of chilled water through the chillers. And even in some cases for big development, where water, for water reticulation system, then these pumps are used to either supply water to throughout the whole development or to an elevated reservoir. And even in, for example, in here, district cooling system, this is taken at the roof of the KLIA International Airport, where we have supplied these pumps to. So now, you have always hear me speak about variable speed. So let me just go a little bit into why variable speed are commonly used for pumps. So, in other words, how does it apply to a pump operation? Now, from an energy saving point of view, the relationship between the flow rate, the pressure, and the speed of the pump will affect the power or the energy consumption of the pump. And at various speeds, the energy consumption will be different. So all this is what we call the affinity law. And this law is a universal law that applies to all centrifugal pump operation. So what is this affinity law about? Is from here, you can see that the flow is proportional to the speed. So what it basically means is that when you reduce the speed of the pump, then the flow will also reduce proportionally. Now, next is the head. Head means the pressure of the pump. So when you reduce the speed of the pump, then the head will reduce to the square of the speed, which means that if you reduce to half, then the head will actually reduce by a quarter. So in short, a small reduction in speed will cause a bigger reduction in head or pressure of the pump. But most importantly is here, where the power of the pump, or rather the power consumption, is actually proportional to the cube of the speed. Yeah. So what it means here is that when the speed of the pump reduce even 20%, then the power that the pump consumes will reduce tremendously by the power of 3. So you can see from here that when we look at a pump curve like this, now very quickly, without going into too much details, when a pump reduces the speed from 3000 RPM to 1500 RPM, which is half the speed of the pump, and here we have what we call a power curve. So the power from here will, let's say at this 3000 RPM is consuming 40 kilowatt, but when the pump reduced to only 1500 RPM, which is half the speed, it will only consume 5 kilowatt. So that means it has reduced by 1 to the 1/8 of the power of the that is required to drive the pump. So in summary, as we mentioned here, pump power has reduced from 40 kilowatt to only 5 kilowatt when the speed reduces by 50%. And all this is part of the affinity law. So it is a law for centrifugal pump, okay? It's not an Eddy Lee's law or Ibarra's law. This applies to all centrifugal pumps. So in summary, what we can see here is that reducing the pump speed by half will result in only 1/8 of energy consumption. That is why there is a lot of advantages when, or rather to run a pump in variable speed because of the power savings that can be realized. Now, apart from just running to save energy, there are also other very good reasons why you need to control the speed of the pump. So from here, we'll just go through very quickly 4 of the most common reasons when you can use when you should use speed control of the pump. So of course, as we mentioned before, to maintain a constant set parameter in your system with varying flow conditions. So regardless of the water demand during the day, you want to maintain a constant pressure. That is where by adjusting the speed of the pump to fix a pressure point, then the pumps will regulate to meet that pressure. So when your demand is low, then the pumps will also reduce the speed to maintain that pressure. And subsequently or consequently, lesser pumps will be used in let's say a package system like what you see in this picture. And secondly, one of the most important benefit of using the or rather controlling the speed of the pump is to reduce or even eliminate the effects of shocks arising from the sudden starting and stopping. So normally in a high-rise building where the pumps are used to pump water from bottom, from the suction tank all the way to the rooftop tank, there's always a case where water hammer can happen because when the pumps stop, then water rushes back by gravity. So by using variable speed, it can actually reduce the pressure of the pump slowly rather than by abrupt stopping of the pump. So with that, it actually reduces water hammering effects. And thirdly is to tune on optimize your pump system to actual system characteristics. Now, what do we mean by this? Now, a lot of case when the consultant design a plumbing system, now he always puts an extra safety there. So maybe he says that, okay, in order to pump water to this point, I need a 20-meter head, but he will always allow for 20% in case because of pipe losses, in case of safety, a bit maybe wrong calculation and so on. So what will happen is that when we select the pump, we select based on the consultant's selection or specifications. But in many cases, when the pump is installed at site, the pump may not need to run at such a high pressure to pump water to that point. So if it's a fixed speed pump, then there's nothing much you can do because the pump pressure is already part of the pump. But with variable speed, you are able to reduce the speed of the pump to just pump enough pressure. So that's very important, because by doing that, we can actually save quite a bit of energy just by regulating the pump speed to, let's say, 90% rather than 100%. And finally, in water supply cases also, during low demand period, for example, like at night, let's say from 9 o'clock onwards, where there's a much lesser water demand, we don't need the pressure of the water to be so high because there's lesser people using. So by having variable speed systems, you can also reduce the pressure setting to, let's say, 0.5 bar less. And in that way, then the pump runs at a lower pressure, but also saves more energy compared to running at the same pressure during the day where you don't need that pressure. So these are some of the advantages of having speed control of the pumps. That's why in a lot of applications consider to use speed control for all the pumps that you use in your site or your installation or in your design. Okay, so if you have, again, any questions, please reserve it at the end of the session, and we can answer some of these technical questions that you have. Now, we'll go on very fast to what we call the pumps that will take the dirty water out. And these are usually what we call either sanitary services, the drainage, and the wastewater services. So as mentioned, whatever that comes into a building must come out, right? So just like our human body, whatever that we consume must come out in the other way. So that's the same like the pumps. And that is the function of these pumps. Now you can see here from this picture that the drainage or these wastewater pumps are the workhorse of the building. Why? You can see from here it is working in the most dirtiest and demanding conditions inside the pit. So because of that, these pumps are actually constructed very robust with solid cast iron construction and extra sealing protection in its body and its impellers, and it even has double mechanical seals. And not only that, but we also offer what we call a QDC, or quick discharge system, where it allows the pump to be removed or dislodged from the piping automatically, so that it can be pulled up easily with a chain hose without having to go into the pit. So it's really a blessing for the maintenance people, because nobody wants to go into a dirty pit like this if they don't have to, right? Now, what is the biggest problem for a submersible pump? Anyone have any idea there? If you can type very quickly into the questions box, then we can see whether you are able to guess what is that problem. Do you have any answers from there, Ahmad? So far?
So far, we have a few questions, but not an answer to that yet.
Okay, so that's still good, because at least people are listening.
Yeah, there are a few questions.
Okay, so for the audience out there, what do you think is the biggest problem for a submersible pump? Anyone? Can you just type very quickly what you think would be the biggest problem? No? So far, no? I think many have gone to sleep.
Yeah. We have some feedback here.
Okay, can you read it?
Right. Mr. Muhammad Siron from University Kuala Lumpur shared that the problem is difficult to maintain,
Okay.
while Mr. Tony Chang from UOA Development Berhad shared that we could have a sensor problem.
Okay, so these are, I guess, some of the experiences that they have faced when dealing with a submersible pump. Now, I will go very simply. The biggest problem for a submersible pump is clogging. Now, why? Let's look at a picture like this. And these are all, of course, real life pictures. Now, you have heard of the MRT station in Singapore, right? That was flooded, and many other examples of basement that were flooded. So, of course, there could be many reasons, but this is one of the reasons why the pump failed, because of clogging. And you can see from here all the rubbish that has gone into the pump. Now, want to see another picture, and especially for those of you who have expensive cars, yeah, and you own a very nice car, and your office is at the 80th floor of the high-rise building, and you park your car at the basement, and this is what happens. On a wet afternoon, your Ferrari or your McLaren is submerged in water. So I'm sure a picture like this sends shivers down your spine, yeah, and also your wallet maybe. So now very quickly, when we talk about submersible pumps, not everything can be pumped out, yeah, and many people do not realize that, and they think that just by putting a submersible pump, whatever water that goes into the pit, it will pump out. But we have to know that there are type of ways that submersible will have problems handling. So what kind of ways are these? One is long fibrous materials. Now that could be any form of very long strings or jute. Just one picture here. Solid waste beyond the impeller channel size. What does that mean? That means every submersible pump have a impeller outlet size, and even for example like IWK uses a lot of sewage pumps and wastewater pumps. So they specify that minimum outlet size must be 76 millimeters. That means anything that is 76 millimeters and below must pass through the pump. So, but in a lot of cases in a building, people don't specify that. So what happens is that a lot of rubbish goes into the pit and the pump gets clogged by trying to pump the wastewater out. And not only that, but some contractors think that if they have a flooded situation, they just put a submersible pump and it will suck out whatever sand, grit, mud in their construction site. And that's wrong, because the pump is not a sand pumper or mud pumper. It's basically a wastewater pump. So the pump will have problems in handling sand and grit and heavy mud. And of course, as we mentioned, too high solid content doesn't mean that as long as you put the pump inside the pit, it will be able to pump out. Because if you have very high solid content in the liquid, let's say beyond 20%, the pump will also not be able to pump out. It will probably get clogged or get stuck. And some rubbish is very, very bad news to the pump, like large cloth, rags, diapers, leather gloves, even clothes and all that, which gets into the sump. This will clog the pump very easily. So be careful when you use such a pump, because you need to ensure that the screen size, and usually the consultant will design a screen be at the inlet of the wastewater into the pit. And this screen size must be either the same or smaller than the pump outlet size. I mean the impeller outlet size, not the discharge pipe size. So in summary, as mentioned, where submersible or wastewater pumps are concerned, it is important to select the right submersible pump with the right impeller to do the right job. And that is why submersible pump have a huge range of different impeller types. Ibarra alone has more than maybe 50 models of different submersible pumps for different applications. And you can see from this picture here, we have various kinds of impellers for different kinds of submersible pump, from a single channel to a semi-open like this, where it can handle some trash, to even a grinder impeller, which is like a cutter action. So whatever that goes in will be grind off, but these are only meant for small, soft particles, yeah, not like hard materials or rats or whatever. Then you will have a problem. You will get stuck here. And even a vortex impeller design where the liquid or the wastewater does not actually go through the impeller, but actually is sucked out through a vortex or a hurricane action. And even that you can see from here, even a ball like this can be able to pass through. So again, many types of designs of submersible pumps for different applications. So there you have it. Without going into too much details, these are 5 of the most common pumps that are used in any buildings. And if you walk into the pump room of the building, you will probably see these pumps in action, yeah, pumping water reliably to ensure that the occupants get a comfortable water supply, or the application, for example, like aircon, gets the right the chilled water temperature at all times. So remember always, finally also, that the pumps inside a building is actually like the pump inside our body. Yeah, so all of us have a pump actually. And of course, you know where this pump is in your body. Yeah, so you must treat it well so that it will also serve you well for a long time. Yeah, and especially more during this coronavirus pandemic. We hope you also stay safe and follow our government's orders, yeah, and ensure that you are always protecting not just the surrounding, but also your heart at all times. And just before we end, since it's part of the IGEM event, it's also time to think green when you select the pumps for your building. So our Ibarra pumps are certified both under Malaysia GBC as well as under My Hijau program. So most of our pumps for building services, for example, like the multi-stage pumps, the pressure boosting systems, and the split case and end suctions, are all accredited or certified to green standards under MGBC as well as My Hijau program. And in summary also, in closing, Ibarra, if you have not heard before, is one of the leading pump suppliers for building services and also for water supply, for industrial applications, for water treatment. Even in oil and gas sectors, we are a big supplier to Petronas and many other oil and gas majors. We are fully ISO 9001, 14001 and 18001. And not only that, but we have been approved by many governmental and regulatory bodies in Malaysia for the usage of our products like Jabatan Bomba and JKR, JBA, and so on. So you can be assured that whenever you use Ibarra pumps for your projects, you are dealing with the right product and the right company. So in closing, these are our contact details, and our office and factory is based in Subang Jaya. So we host a lot of visitors to our office for pump testing, for trainings, and for a lot of other events. So at any time when you become our customer or you use our pumps, then you can use some of our facilities that we have in our building, for example, like the testing of the pumps and so on. So now, as we end this, and we mentioned before, we will have some quizzes. So we are just going to go through very fast. And this is the time for some lucky winners. And we will just have 3 questions. And Mr. Ahmad will be the judge here. So we are going to ask you 3 questions, and whoever that can answer the question right will get a gift from us. Yeah. So once Ahmad announced who the winner will be, then give him your email or your name, your contact number, your address, and we will then send you a prize, especially from Ibarra Pumps. So now let's go very quickly to the quiz questions.
Sure, let's.
Yes. So the first question would be, what are the 5 most common pump types in a building? So we want an answer of 5 pump types, yeah? So don't just answer 1 or 2, then we want 5. So Ahmad, once you get the person who get the right answer, please let us know.
Yep. Keep it coming, guys. Keep it coming. I heard that the price is quite lucrative.
It's a 14 days and night trip to a quarantine center.
Okay, we're still waiting for answers from the participants.
Anyone? 5 of the most common pump types in a building.
Anyone? You can type the answer in the question box.
Yes, just type it into the question box, and whoever get the answer right, we will send you the prize.
There's still no answer yet. Let me, perhaps I need to refresh.
Okay, no answer at all? We'll give a discount. Okay, 3 out of 5.
3 out of 5, yeah.
Yes.
See? Anybody would like to try? 3 out of 5 of normal pump, which have been presented by Mr. Eli earlier.
Do we have an answer? Do we have a lucky winner? Or everybody is sleeping?
I think the participants have been actively involved during the earlier question.
Or everybody is shy?
Yeah. Right, another discount?
Well, 3 out of 5 is already 40% discount.
Okay.
Cannot get 40% discount anywhere now. No?
What are the 5 most common pump types in a building? Yeah. Any try from the participant?
Nobody at all.
Not yet at the moment.
None at all, is it?
I'm still waiting.
I hope there are still people engaged in the presentation.
Yeah, they are. Yeah.
Okay, or shall we just reveal the answer?
Yeah, why not? Perhaps you can.
Okay, due to time constraints. So we have covered this very detailed in the presentation. So it's a vertical multi-stage inline pumps, pressure boosting sets, and suctions, horizontal split case, as well as dewatering and drainage pumps. So these 5 pumps would be commonly used in most buildings in any whether it's a high-rise, office, or condominium, or shopping center, or hotels, resorts, and so on. Okay, so next quiz is, what are some of the good characteristics of a vertical multi-stage inline pump? Now, this should be quite straightforward and obvious. So again, we would like maybe 3 out of 5 advantages.
Yeah. Okay, any participant would like to try, you can type your answer in the question box. What are some of the good characteristics of a vertical multi-stage inline pump?
So again, 40% discount. We'll take 3 out of 5. Well, unfortunately, you don't get 40% discount when you buy an Ibarra pump.
Now we have a few questions listed, but not on the answer
Oh,
yet.
the answers. So maybe if there's not much participation on the quiz, because everybody thinks they don't need a prize, shall we move straight to the question and answer session?
Yeah, let's.
Okay, so in that case, then I will stop sharing, and you can now show.
Okay, we have one question here from Mr. Ivan Tan of Kawan Food Manufacturing. The question is about the temperature range for the pumps. What is the operating range for the pumps? Is minus 40 degrees Celsius and below possible? That's the question.
No, it's not possible. So normal water pumps can pump water, let's say from anything from, let's say, 3 degrees Celsius, very chill, all the way to maybe around 50 to 60 degrees. That's very common. Yeah, so anything between 2 to 3 degrees all the way to 50, 60 would be very, very straightforward for any centrifugal pumps. But then we have a lot of application, for example, like boiler feed. Some of our pumps are used for boiler feed where the temperature can be as high as 100 degrees or even a little bit more than 100. And actually, when it comes to above 100 degrees, then there's a bit of vapor inside the water. So in this kind of applications, the pump needs to be selected correctly because there's a lot of cavitation that can occur if you use the wrong pump. But where in applications like minus 40, then it is already a very, very special pump. There are pumps that can do it, but not the standard manufactured pumps from us. These are, for example, like cryogenic pumps and so on, and they are meant for very, very low temperature. So if you do have such a requirement, it will be very, very specific. We have the pumps, but you will need to know all your information, like what you're pumping, what is the environment like, all this before we can actually select the pump for you. And
Okay.
yeah.
We have another question from Mr. Tony Chang from UOA Development Berhad. The question is about let me just read the question. If oversized constant flow pump, can we trim the impeller to help improve the pump efficiency? Right? It's about constant flow pump and how to improve the efficiency for this kind of pump, Mr. Lee.
Okay, so yes, not all pumps you can trim the impeller. Only pumps that are casted, meaning, for example, like split case pumps or end suction pumps that which have casted impellers, then you can trim. But a pump like multi-stage, like what we have gone through, you cannot trim because these are made out of pressed steel. So you can trim the impeller to a certain diameter, but you always have to refer back to the pump curve because there is a range of maximum and minimum, or minimum and maximum diameter that you can trim. You cannot trim, for example, like half because that will lose so much efficiency, and will make the pump not be able to pump properly. So again, follow the curve of that particular model.
I see. Yeah, good reply, Mr. Eddie. Okay. Last question from Asmaniza Asanan from Plus Berhad. The question is about how do we control the speed of the pump? Is it done manually or automatically by a timer or anything else?
No, usually a very good question. In fact, we spoke so much about variable speed, but we did not mention how to do it. Okay, technically it is done by using what we call a variable speed drive. or variable frequency drive, it is basically an electronic power device which is installed usually in the control panel of the pump. And that basically what it does is to adjust the frequency of the supply. So by adjusting the frequency of the supply, the power supply to the pump, then it is also adjusting the speed of the pump automatically. So in short, you will need what we call a variable speed drive or frequency inverter to do that job, to adjust the speed of the pump.
All right. I believe that's all the question that we have from the participants. If there is no new question, perhaps we can continue with the next session. Mr. Eddie?
Sure. So that's the end of our session, right?
Yep. All right.
Okay.
So thank you very much, Mr. Eddie Lee, for sharing with us today. That's definitely a good presentation on pumps and also green building, right? Just a side note to the participant, the organizer will be sending a survey form via email to all participants. Please help to fill in the survey form. Also, before the end of today's webinar, we would like to promote Malaysia GBC upcoming events in August. The first one, we have another pocket talk titled An Innovative Engineering Technology Towards a Clean and Sustainable Environment on the 18th of August at 4 p.m., right? A 1-hour session. And then on 24th of August, we're going to have another pocket talk titled Steel, Sustainable Construction Material in Modern Urban Development, 4:30 to 5:30 p.m., 24th August. And then the next day, on 25th of August, from 2 to 6 p.m., we have a webinar with the title Building Out Waste, Transforming Waste in Construction and Demolition. While on the 28th of August, 9 a.m. to 1 p.m., we have Academic Research Collaboration Reactor Program, ARC Reactor 2021. All right. I believe that's all from us. Thank you again from your kind participation. Thank you again, Mr. Lee, for the presentation. Take care and stay safe, everyone.
Thank you, everyone, from all of us at Ibarra.
Thank you.